Hello everyone. We're here to discuss one of our 13 keys to the kingdom, that being something called Euler's number. And so Euler's number walks around your calculator as something like that. If you think about one of the most beautiful equations is Euler's identity, which is e to the I pi plus 1 equals 0, or by algebra, if you subtract 1 from both sides of this equation, you have e to the I pi equals minus 1. You can get a feeling for at least one of the places that e shows up, but we have to realize that e shows up in a lot of places. So remember, e is Euler's number. And like many great numbers in mathematics, you can get at e a number of different ways. So if we start with this discussion thinking that we're trying to base it on, at least in some way, shape, or form, students in around 3rd to 4th grade, or ourselves, 3 to 4 years after anything, starting school, starting college, starting life, starting retirement, we want to think about getting to memory of what it was like to learn 390 math facts. And I'll point you back out your times tables, your addition tables, and the like. So one of the things we're going to try to do is try to see what we can do with Euler's number to get to a point where you can use your math facts. And we won't be perfect at it, but here is one of the places, one of the ways to calculate Euler's number. And it is this way. 1 over 0 factorial plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial plus 1 over 5 factorial plus ... The sum, basically, of all of these numbers will end up being Euler's number. Of these numbers, you might ask, and I remember when a student or one of my daughter's friends came from school very excited to be able to use an exclamation point, what does 2 factorial mean? Well, if we think about it, doing it the other way, if we think what 5 factorial means, it's 5 times 4 times 3 times 2 times 1. And 4 factorial is 4 times 3 times 2 times 1. And 3 factorial is 3 times 2 times 1. And 2 factorial is 2 times 1. And 1 factorial is 1. And the odd one is that 0 factorial is also 1. And so this sum, up to a point where you probably have to use your calculator, is a great place to practice your timetables. But for practice your multiplication. So if you think about that, you might say it's the sum. It's also a great place to teach students that summation symbol. And you might want to do it backwards or forwards. 1 over 1 plus 1 over 1 plus, that won't help, 1 over 1 plus 1 over 2 times 1, which is 1 over 2, plus 1 over 3 times 2, which is 1 over 6, plus 1 over 3 times 2 times 4, or 2 times 4 times 3 times 2, which is just 4 more times this, which is 6 times 4, which is 24, plus 1 over 5 factorial, which becomes to be 24 times 5, which is 60. And the students can then see this pattern of this number getting smaller and smaller. And if in fact you're like my daughter's classroom, you might want to then do decimals, but if you're like Thomas Wolfram or Conrad Wolfram, you might take out the calculator and see that this turns out to be 2.713, and it goes on ... It is an irrational number, and it is Euler's number. So what is one of the routes you get to get 2.713 Euler's number? It is 1 over 0 factorial plus 1 over, the sum of 1 over 0 factorial plus the sum over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial plus 1 over 5 factorial ... which turns out to be this. Or if you think about it this way in terms of limits, but you really don't have to use the word limits when you're only 3 to 4 years out of something, or 1 year after learning, or in the middle of learning 390 math facts. Euler's number is also 1 plus a very, very small number multiplied by itself an infinite number of times. And so one thing you could do is have students look at that small number starting maybe as, or a large number as a 4, 1 plus a quarter to the 4th power, and calculate that number, and then to 1 plus a 5th to the 5th power, 1 plus a 6th to the 6th power, and this time you're not summing it, you're just kind of watching how the number progresses through space. 1 plus a 10th, when you jump to that, to the 10th power, 1 plus a 100th to the 100th power, and it will also get you eventually to Euler's number. So, Euler's number is one of those numbers that doesn't necessarily jump out of our classic construction, even though you can finally know that on a certain graphing system where you have something here, right, the radius there and an angle theta, from 0 you can tell people that actually it is the circle. The formula e to the I theta graphed on the complex plane or the Gaussian plane is it is the circle, which is the key to number one of these 13 things. So we have looked for the first time at the non-geometric, the sequence and series, the limits of Euler's number, it being one of our 13 keys to the fun math kingdom. I will be next. Thanks for listening.